Hello friends, welcome to AKS. Today we are dealing with a topic called Aditya Mission. See, as we are discussing science and technology series, in that we are discussing space. We have already discussed introduction to space technology, genesis of Indian space program, different types of orbits, different types of satellites and launch vehicles. Orbits we have discussed low earth orbit, high earth orbit, medium earth orbit, geosynchronous earth orbit, and launch vehicles we have discussed ASLV, PSLV, GSLV Mark III, RLV-TD and Scramjet technology. See, there is a playlist in space technology you can watch for further understanding of these topics. Sun is a very important source for our energy. For example, plants with the help of sunlight only do photosynthesis. Through that only they become the primary consumer and then we become the secondary consumer. In the same way, animals also depend on plants which depend on sunlight. So sun is a very important source for us to understand any topic further. So we were trying from long back that what is the composition of sun, what are the different gases which are present in sun, though it is not humanly possible to enter into the sun or very close in proximity, but we can observe sun from a little distance. So sun is always a mysterious one and we have tried or we are trying from the very beginning of the mankind, and India is now planning to launch our own Aditya mission in 2020. So you have sunspot, you have some topics like sunspot cycle, solar flares, wherein the sun releases energy and they come and obstruct the different satellites which are there in space, and they affect planets, comets, asteroids, everything. So sun and its composition needs to be understood. Sun has chromosphere, photosphere and corona. See, if you see, this is the core and this is the radiative zone and this is the convective zone. If we observe the earth also, we have the same, like you have core, crust and mantle. In the same way you have this, and the middle part is very hot. So in this way solar wind is passed from sun. Our primary focus is sun. Sun is the most important galaxy in our solar system. As we know, our solar system has many galaxies, and in that sun is the most important part of our galaxy. And it is important to know sun because we are affected directly by solar flares and sunspots. Scientists believe that a detailed study of sun could help solve many mysteries of our universe and could open doors to many new possibilities of extending our life system to other planets. We have seen the structure of the sun. You have core in between, and if you observe, corona, which is the outer layer of the sun, is itself at the temperature close to 6000 Kelvin, and scientists are looking for an answer about how does this corona gets heated so much despite being thousands of kilometers above the sun's photosphere. That is to say, see, if this is the core, this is the corona, so still here also the corona is itself 6000 Kelvin, being so far from the actual place. So the corona gets heated even being so far from the photosphere. Aditya L1. So Aditya is the mission, L1 is a Lagrange point. What is it? We'll understand in the coming slides. Aditya L1 is a spacecraft designed to study different behaviors of the sun. It has been designed and will be built in collaboration with ISRO and other various Indian research institutions. It is planned to be launched by April 2020. The Aditya L1 mission will be inserted in a halo orbit. What is halo orbit? We'll see. Around the L1 point, which is about 1.5 million kilometers from the Earth. The 1500 kg satellite which we want to send carries 7 science payloads. Each payload has different diverse objectives, which include coronal heating, solar wind acceleration, coronal magnetometry, origin and monitoring of near UV solar radiation. So, Aditya L1 mission will be put into halo orbit around the L1 point, which is about 1.5 million kilometers from Earth. So, it is 1500 kg satellite we want to send, and it carries 7 payloads. What are they? We'll discuss. Aditya L1 has coupling of solar photosphere to chromosphere and corona. In situ characteristics of the space environment around Earth by measuring energy particle fluxes and magnetic fields of solar wind and solar magnetic storms have adverse effects on space and ground based technologies. See, the solar wind and solar magnetosphere storms, actually they send in the rays. So, with that, they affect both space and ground technologies. For example, we have put a satellite over here, and these solar flares or sunspot cycles disturb the satellite, and sometimes they can destruct the satellite also. Scientists are also in the optimism that a detailed study of sun could help solve many mysteries of our universe and could open doors to many new possibilities of extending our life system to other planets. Aditya L1 will also be India's first mission to be placed at the Lagrangian point. See, Lagrangian point is a place far away from the Earth from where continuous solar observations are possible. That is, this is a place wherein you can observe sun comfortably, which is also very far away from the Earth. Only two space organizations, namely NASA of USA and European Space Agency, have successfully placed satellites at the L1 point as of date. That is to say, only two organizations, NASA and ESA, were successful to place the satellites at the L1 orbit. Halo orbit. Halo orbit is a periodic three-dimensional orbit near L1, L2 and L3 Lagrange point in a three-body system. The Lagrange points are positioned in space where the gravitational force of two body systems like the Sun and the Earth produce enhanced regions of attraction and repulsion. See, these are positions in space. See, for example, this is Sun and this is Earth. So, the gravitational forces of two body systems produce enhanced regions of attraction and repulsion. This technology can be used by spacecraft to reduce fuel consumption needed to remain in position. Generally, a lot of fuel is required to rotate, but if at all they can sit in this position and watch, the fuel consumption will get reduced. Lagrange points. There are 5 special points where a small mass can orbit in a constant pattern with two larger masses. We'll see a picture to understand better, but just understand, a small mass can orbit in a constant pattern with two larger masses. There are 5 such points which are known as Lagrange points: L1, L2, L3, L4 and L5. The Lagrange points are positions where the gravitational pull of two large masses precisely equals the centripetal force required for a small object to move with them. That is to say, two bodies' gravitational pull and the centripetal force of the small object are equal when they are positioned at the Lagrange point. So, these are the Lagrange points: L1, L2, L3, L4 and L5. See, this is the sun and this is the earth. We are putting or trying to put satellite here so that it can watch sun from a distance, and these are other Lagrange points L1, L2, L3. If you see, they are all in a straight line, and L4 and L5 are beside. So we will understand each point and their importance. Of the 5 Lagrange points, 3 are unstable and 2 are stable. The unstable Lagrange points are labeled as L1, L2 and L3, which lie along the line connecting the two large masses. The stable Lagrange points labeled as L4 and L5 form the apex of two equilateral triangles that have a larger masses at their vertices. L4 leads the orbit of the earth and L5 follows. We have seen this is the straight line L1, L2 and L3. Here you have L4 and this is L5. So the points are clear. That is, L4 and L5 form the apex of equilateral triangles that have the larger masses of the vertices. L4 leads the orbit of the earth and L5 will follow. The L1 point. See, the L1 point of the earth sun system affords an uninterrupted view of the sun and is currently home to solar and heliospheric observatory satellite, which is called SOHO. The L2 point. L2 point of the earth sun system was the home to WMAP spacecraft. This is a spacecraft which was sent, and now the L2 point is home to Planck and future home of James Webb Space Telescope. This is important. So what they will do is, as we have discussed, this is L1, this is L2, L3, L4 and L5. So they will put here the James Webb Telescope and observe, and now it is the home of WMAP spacecraft and Planck. So L2 is, that is L2 point, is ideal for astronomy because a spacecraft is close enough to readily communicate with Earth and can keep Sun, Earth and Moon behind the spacecraft for solar power and provides a clear view of deep space of our telescopes. So L2 point is generally used for astronomy, that is to observe. It provides a clear view of deep space of our telescopes. The L1 and L2 points are unstable on a time scale of approximately 23 days, which requires satellites orbiting these positions to undergo regular course and altitude corrections. That is, L1 and L2 are unstable, as we have seen, on a time scale which is 23 days and requires satellite orbiting positions to undergo regular course and altitude corrections. That is, they need to be changed. So L3 point, see, we have discussed sun is here and L3 point is here. As it remains hidden behind the sun at all times, it is difficult to trace. L1 is here, L2 is here, L4 and L5 are here. So L1 is a good place, L2 is a good place to put the satellites. L3, as it is behind the sun, it is difficult to trace. The L4 and the L5 points are home to stable orbits so long as the mass ratio between the two large masses exceeds 24.96. This condition is satisfied for both the Earth Sun and Earth Moon systems and for many other pairs of bodies in the solar system. So let us understand Lagrange points. See, the forces are strongest when the contours of the effective potential are closest together and weakest when the contours are far apart. For example, if we see generally, L4 and L5 correspond to hilltops, and L1, L2, L3 correspond to saddles. Saddles means that is points where potential is curving up in one direction and down in another. These are called saddles. If you see horse back has saddles, in the same way L1, L2, L3 are saddles position, and L4 and L5 are top of the hill positions. So this is another picture to make it clear. See, this is the L1 point, this is the L2 point, L3, L4 and L5. As we are discussing, L4 and L5 are like hilltops. Can watch. L1, L2 and L3 are in a single line and are like saddles. There are 7 payloads which are being carried. First is the magnetometer. This measures the magnitude and nature of the interplanetary magnetic field. Next is solar ultraviolet imaging telescope. See, this will resolve solar photosphere and chromosphere in a near UV range and will measure solar irradiance variation. The next one is Aditya solar wind particle experiment. See, this helps in study of variation of solar wind properties as well as its distribution and spectral characteristics. So these are 3 payloads which are present. The fourth one is high energy L1 orbiting X-ray spectrometer. See, this will observe the dynamic events in a solar corona and will provide an estimate of the energy used in accelerating particles during eruptive events. The next one is visible emission line coronagraph. See, this will help to study parameters of solar corona. We have seen what is corona, and dynamics and origin of coronal mass ejections. The next one is plasma analyzer package. See, this will help in analyzing the variation of solar wind properties. Next one is solar low energy X-ray spectrometer. This will help in monitoring X-ray flares for studying the heating mechanism of the solar corona. So the purpose of Aditya L1 is to provide the scientist an opportunity to understand the dynamical process of the sun and address some of the outstanding problems in the solar physics. On this note, thank you very much.